Okay, this is a really quick video about something that I've been working on. I was working on in December and just hadn't had a chance to make a video about it yet. I was reading this book by Professor Stewart. It reminded me about the three-body problem, which to summarise really quickly, if you use Newton or Einstein and say, for example, you have the Sun in the middle and you have the Earth orbiting around the Sun, so you've got two bodies, you can show that the orbit of the Earth around the Sun is an ellipse. As soon as you add in a third body, so for example, if you wanted to calculate the orbit of the Earth and Mars, and you wanted to take into account the effect of all three bodies on each other, then you can't work out what shape that orbit's going to be. Oh, and this became a really important problem, and I think it was after Newton this became an important problem, because obviously you think, well, if you've got, like, there are three bodies that are really important to us: the Sun, the Earth and the Moon, and you'd think that if you had a decent theory, you'd be able to use that theory to calculate the movement of the Sun, the Earth and the Moon. So you still can't say for sure that these three bodies are going to behave in this way. But what you can do now is you can model that in a computer. So I was reading about this and I thought, well, I'm trying to learn Python anyway, so why don't I try and write my own program? And, you know, thinking about it from the perspective of, you've got the Sun in the middle. I think, you know, I was thinking initially to say the Sun. I think what I was going to do initially actually was just put the Earth on it. So have the Sun and the Earth, and then give the Earth some initial position and velocity, and then you can calculate the force on the Earth, turn that force into an acceleration, and then use that acceleration to update the velocity, use the velocity to update the position, and then just keep looping around. I think I had the approach right in terms of sort of stepping in time and recalculating the position and velocity on an ongoing basis, kind of looping round. That seems like the right way to do it. But it turns out I didn't know Python well enough to do a good job of it. So I went and found somebody else's code, and they had used Turtle. Anyone remember this logo and the turtle? They'd used Turtle in Python. They'd modelled a few planets, but they'd done it in a certain way. So I think they'd put the Earth to the left of the Sun, and then they'd put a couple of the other planets to the right, all in a straight line, and then use the average orbit speed for each of the planets to just get them moving in a circular orbit. I borrowed that code, and then I made a whole load of modifications to it, which is, I always think, a really great way to learn a programming language. Just a quick word about the algorithm. I really like the way that this program works, because it uses very much an object-oriented approach, which kind of makes sense because you're literally talking about objects that are all kind of influencing each other, so it kind of makes sense. And the way it works is that it's this big loop that takes each planet at a point in time. For each planet, it calculates the force on it from all the other so for each object, it calculates the force on it from all the other objects, calculates the magnitude and direction of the force, uses that to update the acceleration, uses the acceleration to update the velocity, uses the velocity to update the position. Keeps looping round all of the objects. Once it gets to the end, it just starts again, and then it just keeps updating the positions. The program, as it was presented to me, would keep all the previous iterations, so you ended up with a circle for the Earth and a circle for Mars and so on, all going around the Sun. I mean, in theory, it is calculating the effect of all the planets on the Sun, so in some infinitesimal way the sun is also moving, but of course you can't see that. So what changes? So I've done a blog post. My blog post is on birminghammaths.wordpress.com, so you can go there and you can copy the code. I'll probably put I'll definitely put a link to that under the video, and I'll put probably a copy of the code under the video as well. So what changes did I make? There were a lot of trivial changes, but the most important things, I wanted to take the actual positions of the planets at a point in time, which I found from this JPL site. I was able to find the actual positions of the planets on the 26th of December, so I used that as my starting point. And there's just one thing that I would change, if I could change it about the code. All the different sources that I went to were telling me, I think, almost like the average orbit speed, and if you use that, what you end up with is a circular orbit. So I think that all of these planets here are going in a circular orbit. I found that you could, if you used a slightly different velocity from the average, then you could get the planet to sort of, because it's going a little bit too fast, it moves out and then it moves back in, and you can see then that it's an elliptical orbit. But I couldn't find accurate numbers that I could use to do that, so I just went with the average. So I had to make some changes to the code. So I had to change the way it worked, so that there are a couple of things. Different planets, different sizes, so they're the right relative size. I put in what angle, so I modified the code so that you could specify the distance of the planet from the sun and then the angle that it was at. All of this is in the blog post. If you've got any questions or any comments, particularly if you know where to find information about what I'd love is the position and velocity of all the planets at a point in time. If I could get that, then it should be a more accurate model than the one we've got here. So I've waffled on for ages. Thank you for watching. Please go to birminghammaths.wordpress.com. Thank you for watching. Please like and subscribe. Thanks a lot. Bye.